In this video, we're going to take a look at compound inequalities. So that means more than one inequality or more than one constraint. So there's two different types of compound inequalities. You can have an and situation, and that means that they both have to be true at the same time. In other words, we're looking for an intersection or an overlap. And then our other situation is or, and that's going to mean either can be true. So if either situation is true, then it's true. This is similar to a union, or you can look for example, any shading. So basically anywhere that it's true, the whole thing is true. For and, all pieces have to be true at the same time. Okay, so let's look at some basic situations with these compound inequalities before we try to solve anything. So let's say that we have x less than 4 and x greater than or equal to -2. Okay, so both of these have to be true at the same time. So let's look at a number line because it's the easiest way to see it. So -2 and 4 are our numbers. You can fill in the rest if you'd like. Okay, so we want to be less than 4 and we're not included. So less than 4 is going to go this way. Okay, and not included means that we have a round bracket facing that shading. Okay, now greater than -2 means that we're going to shade this way, and we're going to have a square bracket because it is included. Okay, now for an and statement, we're looking for the overlap. If you want, I can do this in color as well. So less than 4 went this way, and greater than 2 went this way. And so we're looking for the places that had both red and blue. And so you should be able to see in here is the overlap. Okay, so what region is described by this compound inequality? Well, it has to be the overlap, so it goes from -2 to 4. So you could write it as x is between -2 and 4 that way. Okay, -2 is included, 4 is not. Or you can write it as the interval, -2 to 4. Remember, always go left to right. -2 is included, 4 is not. Okay, so that's an and situation. We've got shading everywhere, but we're only looking for the overlap. Let's try another one. Let's say we've got x less than 3 and x less than 1. Okay, so 1 and 3 are our numbers. And this time I will use a different color. Okay, so I'm going to do x less than 3. So that's going to go to the left. Okay, there's x less than 3, and that's going to have a round bracket. And I'm going to have x less than 1, so that's going to go left of 1. And that's also going to have a round bracket. Okay, so where did we overlap? Pick another color here. Okay, so we overlapped right here. All right, so when we can write that as an interval or as an inequality, but usually we're going to write it as an interval. So going from left to right, we've got -infinity to 1 is our interval. We're not included at infinity ever, and we're not included at 1 because this one's not included. So even though the green shading goes through it, it's included in the green, it's not included in the red because it's not included at 1. So remember, it has to be included in both of them. Okay, so we've got -infinity to 1 for that one for our final interval. Okay, and then let's do one more. Let's say we've got x less than 1 and x greater than 4. I'm running out of space a little bit here. Let me move this. Move that out to the end there. Okay, so let's draw it on the number line. Oops. Okay, so 1 and 4 are the numbers that we're looking at. We've got to make sure we put them in order here. Okay, so this one, let's do this one in red. I'm going to have x less than 1, so it's going to go this way. and it's not included, so that's a round bracket. Okay, and then the other one I'll do in purple just for fun. We'll have x greater than 4, so it's going to go this way. And it's also not included, so it's a round bracket. Okay, and now remember for the and statements, we're looking for the overlap. So where do these two things overlap? They never overlap, and if they never overlap, that's going to be no solution, which is the null set, which means nothing, the set that has nothing in it. Okay, so that's the idea for and statements. It's where they both exist. You're looking for the intersection or the overlap. If there's no overlap, then there's no solution. Okay, now let's look at the or situation. So for or, anything that's a solution counts towards the solution. So anything that's valid is going to be valid. So it can be in either interval, we're looking for the union, or anywhere that it's shaded. So let's say that we have, let's say we've got x greater than -1, sorry, not and, or x greater than or equal to 2. Okay, so let's graph that. All right, so here's -1, here's +2. All right, so I'll do red for this one. So greater than -1 is going to go to the right like this. Okay, and that's going to be a round bracket because it's not included. All right, and then x greater than 2 is also going to go to the right. Let's see if I can do that without covering the other one up. Okay, also going to go to the right, and this is a square bracket like that. Okay, now remember for this one, the solution is anywhere that we have shading. So anything that is shaded counts. So we have everything from -1. We don't have anything here. We've got everything from -1 to infinity because any shading is going to count. So -1 to infinity, we're not included at -1 and we're never included at infinity. Okay, so for the and one, they have to overlap. For the or, it's anywhere that they're shading. Let's try another one. Let's say we've got x less than 3 or x greater than or equal to 0. Okay, so let's graph this one as well. All right, so let's say we're going to graph, oop, I need to mark my thing. Here's 0 and here's 3. Okay, we're going to do x less than 3 in orange. So that's going to be that part. And that's going to be a round bracket. And then we've got x greater than 0. Let's do that in blue. Okay, so greater than 0 is going to go that way. And that is included. That's going to be a square bracket. Okay, so now you look for any place that there's shading because it's an or statement. So anywhere that there's shading, we see that the whole thing is shaded. So we've got everything from -infinity to +infinity. Okay, and that's sometimes called all reals, meaning the whole number line. -infinity to +infinity is the correct interval though. Okay, so that's the basic idea with, well, there's one more combination we can do for or. Let's do, let's see, x less than 1 or x greater than or equal to 5. We got one more combination we can do. All right, so here's 1, here's 5. Okay, so x less than 1, we'll make that purple. So that's going to shade to the left. And it's not included, so we're going to have a round bracket. And then x greater than 5, we can do that in orange. So that's going to shade to the right. And that's going to be a square bracket. Okay, and since this is an or statement, we're looking for anywhere that we have shading. Okay, so see over here in the and statement, there was no solution because it had to be both. But over here, it can be anywhere that we have shading. So we're going to go negative infinity to 1, going left to right, negative infinity to 1. We don't include infinity. And we see here that 1 is not included, round bracket also. And then we also go from 5 to infinity. Infinity is never included. And we look right here, we look at the brackets, and we see that 5 is included. Okay, so square bracket there, round bracket there. Okay, so that takes us through all the possible combinations of answers that you can get for and statements and or statements. So and has to overlap, or is any shading.